Yeah, why not?
We're going to throw tomatoes at today?
That's, yeah, send tomatoes, death threats, everything to my P.O. box. No, go ahead.
So I'm Stephen Atwell. I'm a product manager these days. Before that, I was a software engineer, and before that, I was a DBA. So my first job back when I was 14 was in the Museum of Flight down in Tuckawilla's IT department. I was the second employee in it and ran all of their databases, also wired their networks and various other things. And these days, I work in the CI/CD and database space, but no longer as a DBA.
Chris Crow, like I mentioned, I actually work for a technical marketing department inside of Portworx, which is a software-defined storage solution for Kubernetes, which is inside a much larger company called Portworx, which mainly means people leave me alone, and I do a lot of the provisioning stuff around our learning labs for things. So if you go, ever go to a website and click on something and you get an actual environment to learn a thing or two about a particular thing, I'm doing the back end of that stuff, which has actually been just a really fun time. Learning all of the provisioning stuff and everything. And my background actually comes from open systems, particularly Linux systems up through virtualization, networking, storage, and have spent some time as a solutions engineer, architect, post-sales person, that sort of thing.
Cool.
Professional bash coder, I guess.
So we're going to talk about some of the things that you can do with data in CI/CD pipeline. And this talk's been kind of slowly evolving.
Yeah.
So this is, I'd say, what, V2, V3 of our talk?
Yeah.
So the original talk was, leveraging production data for testing your application in like a test environment, which was a big challenge at a prior company of mine. And when I met Chris, like we talked about it, and then he built something that did it in 2 days, and it was. I genuinely hadn't realized that it had become that easy to move data around. And then our talks evolved. So this time, last time we did this talk was Data on Kubernetes Day at KubeCon last year, and it was focused on leveraging test data for deploying a new database server upgrade. This time we're going to be focused a little bit more on database schema migrations. So similar talk, also, but definitely not the same concept.
Yeah, and it really came out of this idea, kind of, because I didn't come natively into the Kubernetes space, being kind of a Linux nerd, was what if because Kubernetes as a concept started in a lot of ways for ephemeral workloads, and I think a lot of people are still there. So you spin up a container, and then when it's done doing its job, when it needs to die, whatever the thing is, you throw it away, and every bit of data on there goes with it. But there's a lot of things about a container environment that are attractive for running applications that require some sort of state. Because after all, when we look at deployment pipelines for applications, we can do neat things. First, we can use all declarative language to spin things up. Things automatically configure. We can spin up new environments without having to do anything imperative. Where it used to be when I started, somebody gave you a server, then I installed SQL or MySQL on it, and then I had to patch it, and then I had to do all of these things in order to get something ready to go, and now we just sort of push a button. Yeah. Well, this has been the case with containers and Kubernetes for a while, but we're starting to see, and hence the original talk on a Data on Kubernetes Day, of bringing the actual persistent data, and it's kind of a weird concept, saying that, hey, we're going to put a database on something that we are okay with throwing away. But because the entire structure around this is stored as infrastructure as code, it also means we can do a lot more with it. Test environments are easy. We just copy and paste some YAML and another environment comes up, minus the data. And that's what we originally set out to solve, coming from actually one of your previous employers, that the only good way, I never tell the story right, the only good way of testing a change in the database, a change in the application, was to actually run it against a set of data. Yeah. So we said, well, what if, since after all, our software
the employer was
developers,
we built our own database, we built our own BI solution. It was as complicated as a programming language in terms of configurability. How do you find the bugs that matter? Yeah. Well, you load up the new version and the old version, you run all the math for 48 hours, then you compare all the numbers in the report.
Yeah.
And anywhere they change, you better know why.
Yeah. And because after all, we're getting more, and I'd say one of the biggest things about using pipelines for deployment is we can integrate automated testing with it. We can integrate, and so so it's kind of all about this velocity, about how quickly we can iterate. But sometimes we need data with it. So that's what really started this idea is, hey, how can we push data around and do things with it as part of a deployment pipeline or a CI pipeline?
So we heard a rumor that some of you like audience participation. So hands up if you like barbecue. Who here likes barbecue? Anyone? Okay, now who here thinks that a barbecue restaurant chain has a database problem? Of course they do. So our application today, we're going to be talking through real-world application. So, you know, Chris's team actually makes and manages a whole suite of software for running fictional barbecue restaurant chains on. And today we're going to be using their inventory management application. It keeps track of all of the fictional barbecue restaurants nationwide. And what's the inventory? Of various foods in various different locations. Fairly simple use case. What's the product look like? It's got a JavaScript web UI talking to a Go backend, connecting to a SQL database, and the whole thing's running on Kubernetes. So fairly simple tech stack. And everything stays simple until you care about having everything be stable with 0 downtime and 5 nines of availability. And thus, this is what our tech stack actually looks like for our simple application. We have a staging, we have a production. We are using Argo CD to deploy the application. We have a Kubernetes persistent volume layer that we're using Portworx for, which is able to do live migration with no downtime of data between clusters. We are using DB Marlin for monitoring of our database. We're going to be using Harness for CI/CD as we start showing you the things you can do with data and pipelines. And all of this, of course, one of the newfangled terms is GitOps, which means rather than pushing buttons on the fly, everything just runs off config checked into Git, which means you can rebuild everything anytime you need. So all of this will be checked into Git, running off a GitOps approach. So what's the story we're going to talk about? So you heard the story from my prior employer earlier. So we're basically going to go through a process that takes our staging environment, spins down the databases in it, pushes all the databases over from production, spins the staging back up using that copy of production data, runs a database migration there. We're going to look at the app, make sure everything's still working. Then we're going to upgrade the app, make sure everything's still working. And then if we still have time, we'll go in and diagnose and fix a performance issue that we happen to have in the change we're going to be pushing.
And I would say that generally, because this is really, because gosh, it has been quite a time of collaboration that between us. That a lot of these things are, because it's a little more than a thought experiment, but really trying to show a real demo of doing something interesting when it comes to how we're managing data and pipelines as part of deployments. And the idea is if we can have some of these sorts of things be automated. So hey, if I'm pushing a particular change, whether that's a schema change, and in this case it is, whether it's an application, whether it's a database upgrade, to be able to run through the same set of automated tests every time on a current copy of data, we're going to catch more issues. Instead of the application guys make a change and they didn't tell you that you needed to do something with the database side of things, or maybe you are going to be doing a schema change but you don't have insight into what the application folks are actually doing as part of their testing and their pipeline. So we're trying to spend some time integrating that stuff together. Is this where we talk about it? So the thing, because there is a change that needs to happen, because when we coded this, and it wasn't actually me, it's fun. It's a suite of applications that one of the guys on my team does for this fake barbecue restaurant. This is the inventory application, but it has, it was like many applications, has a design flaw when we decided to make a particular business decision.
Yeah, and actually really quick before we go there, one thing I want to add. So we're going to be talking about database migration and app deployment primarily today, but that Git repo, that has the definition for our database server. It has the definition for our app. It has the definition for our database schema.
Yeah.
We can change any of the three. They all run through the exact process we're walking through here.
I believe the actual Argo manifest as well.
Yes.
And this is one of, I think, and I guess I should ask, people familiar with Kubernetes at all? Okay, a little bit.
Okay.
So generally, the idea that everything is declarative, so I can express anything about a Kubernetes environment in code, and Argo's job there as an open source kind of delivery truck that we're going to trigger is we make the thing that's sitting in the Git repository identical to what's running on the Kubernetes environment. So all of the changes go through a Git repo, which is the same, and that's why it's important that our schema changes are also sitting inside the Git repo, because everything can be audited that way, and have change control, pull requests, everything that we like about code, infrastructure as code.
Cool. So what's the change we're doing today? So our barbecue restaurant wants to open a new warehouse. We're opening a warehouse in Boston, Georgia, and there's a problem. We currently have a warehouse in Boston, Massachusetts. Our database has a single column for location, and currently it's just storing city names. What are we going to do? Well, time to refactor our database. We want to add 2 new columns, one named city, one named state, and suddenly we can differentiate between Boston, Massachusetts and Boston, Georgia, and life is good. But unfortunately, our barbecue restaurant chain is very picky. They're not willing to take any downtime. They're open 24/7, 365. Great barbecue. Great place to get that 3 a.m. barbecue. So going and moving all of our data from the current column to the old one with no downtime is a little bit more complicated. First thing we need to do is we need to be able to run both the old version of our app and the new version of our app against that database schema simultaneously, because there is some amount of time, maybe it's seconds, but some amount of time where both will be running if we're taking no downtime. In order to do that, we're going to also introduce a trigger, and that trigger is going to be syncing the city column and the location column to ensure that they are consistent and that the old version of the application, if it writes data or updates data, that update will be seen by the new version and vice versa. This also means if something goes wrong, we can roll back. Life is good. Any questions on the change before I kick off and start showing you some code and some demos? Cool.
This is the moment of truth, because of course we have to do live demos for everything.
We like doing live demos. There was a conversation between Chris and I yesterday so all of this is running in his home lab. And unbeknownst to me, apparently he's been having some issues with circuit breakers tripping.
New houses use the arc breakers, which I think have tripped at times. So my wife is waiting by the UPS just in case something happens. Not that it'll be fine for months and months, and then at the most inopportune time, something is going to fail and the entire thing is going to fall through the floor.
Cool. So I'm going to go ahead and commit this change to Git. When I commit this change, it's going to be detected and kick off the entire deployment pipeline we just talked about.
And this is a pretty common pattern for any sort of pipeline, that you have a trigger when code changes to then go and do something, whatever that thing is, which is, I guess, what we're just about to go through.
Yeah. And the change I just checked in, literally it is adding a city column and a state column to my database. And then we are creating some triggers to sync the city and location column. And then last but not least, we add a record for Boston, Georgia. So fairly simple changes. If anyone's unfamiliar with this syntax, this is a Liquibase changelog that I'm using while making this change. If I come over here in Harness, here I can see across all my environments which changes to the database have been deployed where. So these 3 changes, these are the ones I just kicked off deployment of. We'll come back here later probably. And if I come here, we can see the CI/CD pipeline that I just kicked off. What it's going to do initially is it's going to scale down that staging database so that it can replace its copy of data with production. And you know what? I forgot to edit the data in production so that we could show the copies live.
That was the one thing that we said that was
Do you want me to hit abort and we can do that, or shall we let it go through?
Oh, that's good. Let's let it go through. We may have some extra time. We can kick it off again.
That's fair.
So, because generally, if we're making changes into the production data, the real way this demo is supposed to work, we need to add like a big reminder as a thing here, because we have data. So presumably people are making changes to this, and we want to know that whatever change we're doing to the database and the application and the environment isn't going to break something about this. So the best way is, well, we'll make a change to the actual inventory and then watch that actually go through to staging to make sure that everything looks okay.
Yeah, but we didn't make the change. So take our word on it. We did just copy all of the production data over to staging.
And really on the back end, you can think of this as any sort of delivery truck, right? But take some sort of quiesce snapshot of the database that's running in production, ship it over into the staging environment, whether that's going to be incremental, whether that's a backup and restore. I tend to, as an infrastructure guy, stay away from like database dumps just because that's a more expensive process. Better if we can have some sort of storage layer handle that for us, right, and kick the thing over.
So in this case, to do the migration, we deployed a migration CRD to the production cluster, which basically goes and takes a snapshot of the persistent volume that the database is running on and ships it off to staging. And that copy finished, and we forgot to make our modem joke. And we spun it back up. So now we're going to go ahead and do the database schema update.
Yeah. Now, the schema update is happening on the staging environment, though, because we're obviously doing a change, and we don't want this running in production, but we do want it to be running on something
production-like.
Yeah, well, we want a complete verisimilitude. That'll be the, that's the.
After we've verified everything's in good shape
calendar.
in staging, then we'll go run in production. But right now, we're still making sure staging's happy. Cool, so we're running migrations. Over here, we can see the state of the database before we start running it. We're going to go ahead and compute all of the SQL that's going to be run. It gets passed through a governance engine to make sure we're not dropping tables. And then we'll go ahead and run the new ones that haven't been applied yet. So in just a second, after it passes governance, we'll see the new changes that we're going to apply pop in there, and they'll get run. And cool, so we're now updating to the new version of our application schema. And after that finishes, we'll tag the database to create a new rollback point. So if in the future something goes wrong with a later change, we can easily roll back to here. Then we'll go show you the application. It'll still be working. And then we'll update the application to the new version. Cool, we're at that pause. So if I pull up our staging version of our application, the portion of the demo I forgot to do was going and adding to the brisket quantity and over on this manage inventory. And if I come over to manage inventory, well, the new version of my application isn't working all that great, so maybe, you know.
Live demos you may have to do a shift refresh.
But, you know, as you can see, the app's still basically there. I can still come in, I can see all of these. This is the old version of the app still working on the new schema. Hey, that's an important thing for when I get to prod and can't take downtime. I'm going to go ahead and issue the manual approval that I mentioned. And after this, we're going to deploy the new version of the application that is dependent on that change. Only reason for this manual approval is to give us time to talk. Before I hit it, any questions on anything we've talked about so far?
How long will this scale to larger data volumes? So I can get a large application that I'm copying like a couple terabytes of data.
Yeah. This particular system, not well, because I am actually overwriting what's over there. That's where you're going to want something that's probably doing it incrementally. So previous version of this talk, what we actually did is we had the database in the background updating automatically, and then we would do the cutover when we actually ran the test. So it was a little bit of a modification. We didn't add it here, so just because we wanted to show an actual triggering event for the migration. But probably how I would do that is whatever it is should be incremental, shouldn't affect the production data set, and should have a way of stopping that replication in the staging environment, doing whatever change you need to do, and then resuming from a checkpoint after that thing happens, right? Because after all, we've synced everything. we now need to run some stuff on the database and test it, but we need to be able to get back to that point without recopying the 2 terabyte database. And that's typically where some form of snapshot would work. By the way, this is a similar problem to another really common question we've gotten. How do we sanitize or remove any personally identifiable information from that data on the way over? And the answer is typically some type of, on the production side, and you very much want to do this on the production side, right? To, or inside of that infrastructure that's within that security zone, to make some sort of thin copy of that database run through. And I guess the joke is always my last name is Crow, so we're going to replace every instance of Crow with Raven, and then push it over into the staging environment in order to do whatever testing we're doing.
So the company that's QA process inspired this demo. We actually had customer databases that were over 2 terabytes in size. Our cross-site backup for some of our customers was literally handing a person who's getting on a plane a hard drive to take to the other geo. We were able to do this with 2 terabytes successfully. What we did, first we didn't make a separate copy every single time live from prod. We had nightly automated copies of prod, basically via the same infra. And then when we did the on-demand copy, rather than take the copy from prod when it's a high time of usage for that customer, we took from the nightly backup. Still pretty close,
Yeah.
8 hours difference.
And
But
this is where that-
realistically, copying 2 terabytes of data when your product takes 2 days to calculate after doing the copy, not that big of a problem, which was the reality of that particular code base.
And this
So
is where
it
it ends
really
up,
depends on
any
your
of these
app.
things end up being very specific, because as much as possible, whatever tests you're running at this point, you're going to want to be automated. And you're going to want them to be as close to simulating the production side of things as you can get. And so the other question we've gotten is, hey, what sort of tests can you run? I don't have any, because it depends on your application. Like the last one we did actually used, instead of PostgreSQL backend, used a Mongo backend. And what we were doing to run that verification is, again, pretending to be the user, making sure that the actual barbecue orders were there and things made sense. But you can imagine that was an application that I wrote to do the verification and have an API endpoint that something else could query to look at that stuff.
So right here, rather than waiting for manual input, you would typically go run your automated test suite.
Right.
Which is usually very specific to your application. And for some reason, no one has yet submitted any automated tests to our barbecue restaurant chain apps.
We had the QR code and everything at Kubernetes Day. No, not really. But.
Cool. So I just issued that approval, so we're now moving on and deploying the application. So literally what we're doing is we're updating a manifest in Git so that Argo goes and pushes out the new version of the application that needed that database schema update to our cluster. And hey, it just finished deploying. So if I come over to stage now and I refresh, moment of truth, you can see down at the bottom, we now have Boston, Georgia. And my database schema change didn't bother to add states to any of the existing warehouses. One of these days we'll get around to writing that one. So, everything's there. We're now on the new version. Everything worked. So that's kind of what you can do with CI/CD. Now, quick time check, we're doing okay. So I promised, depending on how things went, to show you something about performance. So along the way of everything I've shown you, and ideally before I kick this off, we talk for like 5 minutes. So we might do that. But we've been shooting over to a monitoring solution, various deployment events. So we can see here, we just deployed the new version of the application. And if we look over the last few minutes, you can see, hey, we were not having very much load, like processing time on our database server. And now, immediately after that update, we had this blue bar that is how much time we're spending on queries just went significantly up. And we probably won't sit around here bantering long enough, but if we did, it'll just stay there. Why? Because the new version of the change does have a performance problem. What's that performance problem? Well, the old version wasn't joining those two tables together. It was displaying everything off one table. Off our new schema, when we come over and look at this, now, instead of just reporting off this table, we're having to join this table and this table together to show anything. So, cool.
I would say that this is one of the big reasons to have some of these rollback points. In previous versions of this talk that we've given, even if you can imagine that this same change was in the process of rolling into production, being able to catch a metric somehow that is out of line with what you're expecting, or leaving this running in the staging environment long enough that reports run, or some indication that you have a that you have a performance number that's out of whack with what you're expecting, because after all, we're of course all monitoring this stuff, right? And have performance data. I do it most of the time in my lab, maybe not.
Yeah.
Maybe not all the time.
Cool.
But-
So I'm an app dev. I'm not a DBA. I'm not an expert. But the amount of time we're spending on database queries just went up. What do I do about it? Well, I can come down here. I can find my database query. And if I can remember where the button is, and I am failing to remember where the button is. Is that the one I want? If I could remember where the button is, there's a way to ship it off to ChatGPT to tell me what index to add. But I'm
there
failed. Hey, gotta work ChatGPT in when you can. But at its core, the reason why it's being slow is because we don't have any indexes to support the query that we just introduced. So, cool, we need to make another change to fix the performance problem. We're going to go ahead and add an index on warehouse name, including the name and quantity column, so that we can group on this and display those. We're going to add an index on the location column, which we're using to join the two tables. And then we're going to add a third index on location, including city-state, so that we can group on location and display city-state. And ChatGPT at least tells me that those indexes are going to fix all of our performance problems. And again, just like before, it's all GitOps. So all we have to do is go into our Git repo and write those. In this case, I have pre-written them just to save us a little bit of time. You guys don't want to watch me write database
That would be the
config.
worst type of test ever. Is here, right? Write a bunch of YAML while everybody's watching you.
Yeah, that would be awkward. And just a quick reminder, so far we've only deployed to staging. So while we've got that database problem, it's only affecting our staging environment. After we've fixed all of this, we'll push to prod, and then everything will be good. So I just kicked off that change.
Yeah.
And it's going to run through the exact same process I ran through before. And once it updates the database schema, all of our performance problems are going to go away and become massively better.
That's kind of the key with what we're trying to do here, is keep these environments as close to production so that when we're doing tests, we can catch them. And that the staging environment itself is as close to production as we can make it. And that it's automated at even for whatever part of the infrastructure is actually changing, whether that is a database change or an application change or an infrastructure change. Because some of these systems, although deterministic, can be, I find, sometimes chaotic. And a change that I make in one spot can affect something that I didn't expect somewhere else. We have this probably happen a couple of times a week in my own even lab work that we can pretty closely control at work, where somebody makes a change somewhere and it breaks something unrelated, which is why we run everything through automated systems. Sorry, I think you had a question there.
Just a question. This interface that you're in right now, which shows a pipeline, pipeline, all that, is that like GitLab or is that something different?
So this would be the harness pipeline. So yeah, so it's mine. You can do similar things with GitLab. Any of the database aware functionality that I just showed you that's in here, Harness has that, GitLab doesn't. There's ways to code it yourself.
Bash.
I
one
thought
thing
we
I will
agreed we
say-
weren't going to deep dive into Bash. So for sending that, you may have noticed when I was in the monitoring system, like we had the little events highlighted saying, hey, this changed here. So we are using Bash scripts to send those events. So there is Bash.
It's in there somewhere. Yeah, what I would say is for those that are in a Kubernetes environment, this is where the idea of an orchestrator between multiple Kubernetes environments is really helpful. When I've tried doing this with just Argo, and we're using Argo here, we love Argo, it doesn't, it's very much a lot of Kubernetes deployment tools end up being, we want it to be this way, so we are going to set it this way inside of your environment. And really what we want is, I want you to do this thing, so set it this way. I now want to run this particular test, and some form of branching logic to say, well, if it works, then do this, and if it doesn't, do this other thing. And because we're interacting with two clusters, that's where some of the complication happened when I did this with just an Argo setup. But yeah, it's which I think I have a blog out there somewhere that's kind of interesting, and it does have a bit of bash examples in there.
Yeah.
So.
Well, we were talking to one of you guys before the talk about how, depending on who you talk to, some people want to deploy database schema migrations through the same pipeline as their applications, some don't. A lot of the people, excuse me while I do what I should not do. A lot of the people I talk to actually want to be able to do both. Why? When everything's going happy path, they want to deploy the database, then deploy the app. If anything goes wrong, they want to be able to roll them back together. But it depends on the nature of what the change is. Sometimes, hey, something went wrong, we want to be able to look at things one at a time. Being able to deploy just one without the other can be very useful, especially when it comes to like debugging and diagnosing. Or, in this demo, you may recall that we paused after deploying the schema before deploying the app. Why did we do that? So we could make sure that the old version of the app worked with the new version of the schema, so that when we went to prod and we deployed them both together, we wouldn't take any downtime. If you can't deploy both together, you can't do that. So if you look at something like the ORMs or Liquibase, there's a lot of frameworks that let you, like, on application startup, run migration code. And there's times where that's useful, but it's really nice to be able to run it before you deploy the app, but also to not run it if you don't want it, or to run just it and not deploy the app. Yeah. So having that flexibility can allow you to, write your schema change once, verify backwards compatibility, and then deploy both together once you're ready to deploy both together.
Yeah, I guess if there's nothing else, the one thing that I tend to tell people is, for however you're deploying the change within the stack, whether that is database, application, or infrastructure, to make sure your testing is actually end-to-end instead of just testing the database or just testing the application or something like that. We tend to catch a lot more changes that way. And then, of course, because I love automation, to say, and those end-to-end tests should, as much as possible, be automated, because I'm lazy.
Cool. So, while we were talking, that change finished deploying. So, as you can see here, hey, here's where we deployed the new version of the database schema, and that magic big number you can probably just barely see there from the back of the room. That's the git SHA of the git commit that I just made. That introduced the indexes. Hey, these are the indexes we added, and as you can see, now our time spent is significantly lower. So it had been 45 seconds, and now it's 2 seconds. So, high level, that's kind of what we're doing, and yeah. Any questions?
Comments, death threats?
Yeah.
No, okay.
All of the above are fair game.
Have you considered logical or CDC replications? You set up your stage and or dev environments so you do live redaction on them to keep them up to date?
I haven't. I would be very interested in seeing how that would compare, because there's one of those things that I learn as much as I can. And there's only so many hours in a day. And so at the end, and that's kind of why I mentioned my background at the beginning, because when you're an infrastructure guy, everything looks like replication and everything looks the same. Because I think there could be some really cool stuff that we could do with that. As the infrastructure guy, there's more than one thing that I'm trying to do here. It may not be a database even. It may be something else. So as much as I can funnel stuff into a particular process, but it all depends on what you guys are doing. But that's exactly the point of this. If there's a different delivery truck that's going to work better to move data from one spot to another and kind of fill those same basic things, that it's incremental, we can run a test over here without affecting anything else, and we have a way of rolling back to a point where we can continue that replication without having to transfer that 2 terabytes again, then that's what we're after. Right.
So one of the things that is on my to-do list there is there's another application in this suite that is kind of the end user ordering app, and it's got a login process. And when we show it, step one is log in as C Crow. And it's on my to-do list to tell a similar story with it, and be basically doing the replication from the nightly backup we talked about earlier. And when we restore it, before we restore it in staging, run a database migration off that backup that replaces C Crow with C Raven.
Hence the PII removal.
Yeah,
so.
thus removing the PII. So, at the end of the day, this general approach and framework gives you the ability to do that. But we haven't gone around to building in the PII removal.
I'll give a shout out to, because I saw the Ubuntu guys. So this is actually all Ubuntu Linux machines running out of a spare bedroom in the house using SUSE Rancher's RKE2 engine. So a couple of amazing projects if you're ever after. No one works for Red Hat in here right now, but before I plug them. But lightweight stuff that you can just go and download. I love the stuff that they're putting out from a Kubernetes environment, especially for learning inside of your house, since if I was trying to spin this up in the cloud, I think my wife would have questions about the credit card bill. So,
Yeah, awesome. Any other questions or thoughts?
what do we do on time? Not too bad.
Yeah.
Okay.
Cool. Thanks, everyone. That's everything we had prepared.